there, right? You get these localized buildups. Where are the other places where this can happen? It can happen in the carotids, right? Every once in a while, old people who they think have Alzheimer's, they find out that the problem is just that they have so much plaque buildup in their carotid arteries that they're not getting enough blood to their brains. And if they can clear out their carotid arteries, they function much better because their brains are actually getting oxygen. So all of these places, these fatty plaques can build up as these phagocytic cells get overwhelmed by this extra lipid and die. Now, HDL, not only is HDL a signal that the extrahepatic cells are working correctly, it ends up that HDL also has the ability to sort of absorb fatty materials. So the high HDL actually can absorb some of this deposited lipid as it's circulating and sort of slow the growth of these fatty lipid buildups. So now do we have an idea of what these things are? Does that make sense? I feel like I'm being very deliberate today. Does that make sense? Have we got it straight now, Kyle? Okay? Questions? Okay, so let's look at a couple of details. So, here is the layout of all of these different lipoprotein particles. Okay, so first, right, chylomicrons. We look at, right, they have 1, 2, 3, 4, 5, 6, 7 different proteins that are part of the surface. And while some of them, right, are shared, some of them are unique, right? A1 and A2 is made by chylomicrons, also made by tissues making HDL, right? B48 is specific to chylomicrons. Somebody should have said bingo when I said that, by the way.
Actually, he did.
Did he? Just too quiet? Come on, Evan.
Sorry.
Right? B48.
Yep, bingo.
There we go. Right, B48 is unique to the chylomicrons. B100 is unique to VLDL, and we see that it is retained in VLDL, IDL, and we can see that part of what we lose as this gets smaller and more dense are these other apolipoprotein markers in the LDL. Okay? Chylomicrons are big. Remember when I said that my lymph after my double fillet of fish and fries lunch was probably milky looking? These big particles give it a colloidal appearance. I mean, milk is a colloidal liquid. So we get these big lipid particles that disperse light, whereas the VLDL are much smaller, but we can trace VLDL to IDL to LDL, right? Them getting smaller as lipid is removed. Right? The HDL is much smaller, so there's a much greater portion of protein and polar phospholipid to nonpolar lipid in its core. Any other things on this? Right? You can sort of see the cholesterol content, right? If you combine these two, the cholesterol content of VLDL is somewhere between 15 and 25% cholesterol and cholesterol esters. So we go from between 15 and 25% for VLDL, IDL 38% or so, LDL we're getting to cholesterol of, what would that be, 42 to 50% by mass. So you can just watch the cholesterol content go up as we go from VLDL to IDL to LDL. Right? HDL has a fairly low cholesterol content, but again, these are very small particles. But they can pick up those extra lipids, especially cholesterol, as they are being transported before they get back to the liver and are bound by the liver HDL receptor. Okay? You guys are quiet.
Missing a lot of people.
Yeah, well, it's Friday. We're missing a lot of people today. We're missing 3, which in a class of 12 is a big deal. Right? It's the end of the semester. We're not talking about photosynthesis, which I know has everyone disappointed. Right? We could be doing something like photosynthesis today, but no. Okay? So we've talked about that. We've talked about that. So essentially, this same cycle is occurring for all of these. It just depends on what this receptor is. Right? This figure was built around the LDL receptor. So if this is the LDL receptor, then this could be either IDL or LDL, right? Because they're 2 forms of the same thing. But this could also be the chylomicron receptor, right? Which is the context that we talked about it initially. Or it could be the HDL receptor. And the cycle is consistent for any of those. All right? Are we happy with that? Oh, I'm sure there was a fun point I wanted to make, but let's move on. Okay, so let's metabolize some fatty acids now. Yes, sir.
Real fast.
Uh-huh.
Does HDL have more protein in it than lipids?
I don't know. Let's see.
Just about how it makes it HDL. Yeah.
Well, it's about
Yeah.
almost 50% by mass protein. Yeah.
Okay.
Yeah. Whereas the others are, chylomicrons, they're so large, carrying so much lipid, very low amount of protein. The VLDL family starts at 5 to 10% and increases to 20 to 25% as they mature. Question, Kyle? You're looking thoughtful again. Okay. What? Go ahead.
No, I'm just talking about little macrophage lipid box. That's what I think of now.
Yeah.
50% lipid.
Yeah.
This makes me really worried about what I eat.
It means I should worry about what I eat. I was picking on someone in the organic class that was eating their breakfast. Now, it was one of those she was eating breakfast, and I said, that would be better with bacon. And she said, well, I'm a vegetarian. And I said, well, that's the best reason, because everything vegetarian tastes better with bacon. She didn't like that. But she was sitting there eating a huge pile of eggs. But the eggs would taste better with bacon, too. Anyway, so let's... And syrup?
On
Syrup
eggs?
with bacon. On
I used to
eggs.
think that too, and then someone actually got me into doing that,
Well,
and now it's better.
Most people discover that because they have their eggs and bacon next to their pancakes. And you get the over syrup, and then it's real. The salt of the bacon with the sweet of the syrup.
It depends on the syrup.
That's just good old.
I hate that syrup.
Yeah, I don't
Like Butterworth.
Yeah,
and all
Mrs.
that.
Butterworth?
Ugh.
Oh.
I like,
Oh, that's good. That's seriously good stuff right there. I could just dip bacon in that. That would be fine.
It's good to see them.
we always got real syrup. Like the real maple
The
syrup.
real maple syrup?
Yeah, so the other stuff just tastes really bad.
Okay? Well, the Maine and Vermont maple syrup makers, thank you for your endorsement that is now going to go on YouTube. So, let's talk about metabolism of fatty acids. So the first thing we have to do when we metabolize fatty acids is we have to activate the fatty acids to transport them into the mitochondria, because this oxidation is going to occur in the mitochondria. Okay? So that's our first challenge, is activating fatty acids and transporting them into mitochondria, because there is not a direct fatty acid transporter, right? We know transport into the mitochondrial matrix is highly restricted, right? Pretty much, except for those few things that can cross the little bit of lipid that is in mitochondrial inner membranes, everything else has to cross with a specific carrier. And there is not a specific carrier for free fatty acids. So we're going to start out here activating our fatty acids so that we can transport them. Right?
Nah, I said, well, come on, evolution, you're a little bit behind the curve.
I'm sure there's a reason, right? If we really know, there's probably a control reason, right? Keeping fatty acids synthesized in the cytoplasm separate from fatty acids that are being oxidized in the mitochondria, right? You wouldn't want to just be in a synthetic mode and then randomly burning them in the mitochondria as you were making them. So, right, I'm sure there's a control feature here that makes that reasonable.
Is this before or after, like, this is not when they're attached as triacylglycerol, right?
No, this is after they've been hydrolyzed
Okay.
by a lipase from the triacylglycerols.
Okay.
So the way this usually happens is that fatty acids, either in adipose tissue or in the liver, are released in response often to a cyclic AMP signal. So what are our hormones that could elicit a cyclic AMP signal?
Epinephrine,
Epinephrine or
glucagon.
glucagon in the liver, right? So there is a lipase, they are released, and fatty acids, as they are transported to the tissues, are usually carried by the serum albumin proteins. That's what serum albumin proteins are for. They're for more than being used as a standard in protein concentration measurements in cell biology lab. Right? That's often where we use bovine serum albumin. You know, they're useful for more than coating cellular growth plates to cover up, you know, the reactive sites on the polystyrene. Right? They're worth more than that. So what serum albumins really are for is carrying lipids, solubilizing lipids in the serum so that they can be transported. Right? So free fatty acids, free cholesterol, free steroid hormone molecules are transported in the bloodstream in complex with serum albumin proteins. Okay? So those can be delivered to the muscle cell.